You wake up because something is moving, not outside the shelter. Inside you, your stomach twists, your skin itches. Your body feels weak even though you ate yesterday. You scratch again, then someone beside you starts scratching too. Today, you might call a doctor, you might take a test. You might swallow a small tablet designed to kill worms or other parasites. But in the ancient world, there was no laboratory, no microscope, no pharmacy, and no one could see what was stealing food from inside the body. So did ancient humans really have parasites? Yes, almost certainly. Parasites did not appear when cities were built. They did not begin with farms, sewage, or crowded streets. Many were already following humans and the animals around humans long before written history. A parasite is a living organism that survives on or inside another organism and takes resources from it. Some live in the gut, some live in blood or tissue. Some cling to skin or hair, some stay for days. Others may remain for months or years. The disturbing part is that a parasite does not always want to kill you quickly. A dead host is often a bad home. The parasite may survive by taking a little at a time. Food, blood, energy, sleep, strength. This is the first important twist. Ancient humans did not need to look obviously sick to be infected. A person could still walk, gather, carry, hunt, and care for children while losing resources every day. The infection might cause itching, stomach pain, diarrhea, poor sleep, weakness, weight loss, or almost no clear symptoms at all. That makes parasites difficult to see in ancient skeletons. A broken bone can survive for thousands of years, a worm usually cannot. But the eggs of some parasitic worms are extremely tough. They can survive in dried or mineralized human waste. Archaeologists call fossilized or preserved feces coprolites. Inside them, researchers sometimes find parasite eggs, fragments, or ancient DNA. That is how an invisible infection can leave a visible record. Researchers have reported ascarid-type pegs from deposits associated with the caves of Archaeologists in France, dating roughly 30,000 to 24,000 years ago. That evidence is old enough to place intestinal parasites in the prehistoric world. In western Utah, scientists found human pinworm eggs in coprolites around 10,000 years old. Later research recovered ancient pinworm DNA from prehistoric coprolites in North and South America. Pinworms are especially interesting because they spread easily between people. Their eggs can pass from skin to fingers, bedding, objects, food, and back into another mouth. Imagine a small shelter. Children sleep close together. Adults share hides. Hands prepare food. There is no soap. No sealed toilet. No washing machine. One infected person scratches at night. By morning, microscopic eggs may have moved through the group. No one sees them, but the cycle continues. This does not mean every ancient camp was constantly overwhelmed. Mobile groups could leave contaminated areas behind. Small populations may have limited some infections that require large crowds. But movement did not make people parasite-free. Humans still drank natural water. Handled animal bodies, walked barefoot on soil, shared sleeping areas, ate meat, fish, plants, and insects from the environment, and lived close to dogs and other animals in some periods and places. Different parasites use different doors. Some entered through contaminated food or water, some arrived in undercooked meat or fish. Some passed through soil, some spread through insects. Some moved directly from person to person. At Durrington Walls, the Neolithic settlement near Stonehenge, researchers studied 19 preserved pieces of feces dating to around 2500 BC. 5 contained parasitic worm eggs. Chemical testing suggested that one came from a human and the others from dogs. The findings included fish tapeworm eggs and eggs from capillaried worms. This tells us something more than the simple fact that parasites existed. It reveals behavior. People and dogs were eating foods that exposed them to parasites. The fish tapeworm evidence points to risk from raw or undercooked freshwater fish. Other eggs may have passed through after infected animal organs were eaten. A parasite can therefore become a clue. It can show what people ate, what animals lived beside them, how food was prepared, and where infection moved between bodies. This is why ancient feces can sometimes tell a story that bones cannot. Now imagine your group has caught a fish. You are hungry, the fire is weak, part of the meat is cooked. Part remains cool near the bone, you eat quickly. Days or weeks later, nothing dramatic happens, you do not collapse. You simply begin losing more than you gain, your hunger grows. Your body becomes thinner, you tire sooner. No one connects the weakness to that meal, to danger is delayed. That delay made parasites hard to understand. A predator attacks in one moment. A poisonous plant may cause pain quickly. A parasite can hide behind ordinary life. It may slowly reduce the energy available for walking, healing, pregnancy, growth, and fighting other infections. For children, the cost could be especially serious. A growing child needs energy and nutrients. A parasite takes from the same supply. Even when the infection does not kill, it can make every other challenge harder. Cold feels harder, travel feels longer. Hunger arrives sooner, a wound heals more slowly, the next disease becomes more dangerous. This is the second major twist. The parasite may not be the final cause of death. It may simply lower the body's ability to survive everything else. So what could ancient humans do? They had no modern antiparasitic medicine. But they were not completely helpless. They could remove visible lice and fleas by grooming. They could cut or comb hair. They could clean or replace bedding. They could use smoke near sleeping areas. They could move camp. They could cook food more thoroughly. They could avoid water or foods associated with sickness. They could teach children not to touch certain waste, insects, or animal parts. Some groups may also have used plants that affected pain, digestion, or worms. But we must be careful. We cannot assume every traditional remedy worked. We cannot turn every bitter leaf into a cure. Knowledge was local. Some practices helped. Some probably did nothing. Some may have caused harm. The most reliable defenses were often simple. Heat, distance from waste, cleaner water when available, careful food preparation, grooming, changing sleeping material, and memory. Someone notices that a certain fish causes sickness when eaten raw, the group cooks it longer next time. Someone sees that children become itchy after sleeping on old bedding, the bedding is burned or replaced. Someone discovers visible worms in human waste. The camp learns that something inside the body can come out and spread. They may not understand eggs, life cycles, or microscopic transmission, but they can still recognize patterns. Ancient medicine often began with pattern recognition. What happened before the sickness? Who became sick next? Which food was shared? Which water source was used? Where did everyone sleep? That knowledge would never be perfect. Parasites are built too high. Many eggs are invisible. Many symptoms look like other illnesses. And some infected people feel normal. One person may carry many parasites, while another carries few. The burden is uneven. That means two people in the same camp could eat the same food and have very different outcomes. To ancient observers, this could make the world seem unpredictable. One child becomes thin, another stays strong. One adult suffers stomach pain, another shows nothing. The cause is shared, but the result is not. There is another uncomfortable truth. Parasites may have been so common that some symptoms felt ordinary. Itching at night, occasional worms in waste, recurring stomach problems, periods of weakness. People may not have viewed every infection as a special event. It was simply one more cost of being alive, like insect bites, cold nights, small wounds, and hunger. Modern people often imagine ancient survival as a series of dramatic battles. A mammoth hunt, a wildfire, a predator outside the cave. But survival was also a quiet struggle against small things. Things too small to see. Things that lived inside the body. Things that stole a little every day. Return to the shelter, your stomach still twists. The child beside you scratches in sleep. An elder checks your hair. Someone adds fresh grass beneath the hides. Someone moves waste farther from camp. Someone cooks the fish until the center is hot. No one knows the word parasite, but the group is learning the shape of an invisible enemy. So did ancient humans really have parasites? Yes. Pinworms, tapeworms, roundworms, lice. Fleas, ticks, and many others, depending on the place, food, climate, animals, and way of life. Not every person carry every parasite. Not every infection cause severe disease. But parasites were part of the human environment long before modern medicine. They traveled with us, fed on us, adapted to us, and sometimes left their eggs in the only place archaeologists would find them thousands of years later. Ancient humans survived parasites not because their bodies were magically immune. They survived because many infections were slow, because some people resisted better than others, and because human behavior reduced risk even without understanding the microscopic cause. Fire helped, cooking helped, movement helped, grooming helped, memory helped, and as always, the group helped. The most dangerous animal in the ancient camp may not have been standing outside the firelight. It may have been living quietly inside you. If you enjoyed this journey into the distant past, subscribe for more stories about ancient humans and human evolution.